Good evening, His Excellencies, distinguished guests, colleagues, and participants. Thank you all for partaking in this webinar today. Today, I would like to speak about an unconventional yet increasingly important topic of the importance of liberal arts in the space of underwater domain awareness, how advancing UDA's discourse requires liberal arts subjects. When we think of UDA, we often think about naval ships, submarine sonar systems, AUVs, and other technologies. While there are undoubtedly essential components, they represent only a part of the solution. The underwater domain is not merely a technical and military space, but it is also an environmental, economic, cultural, legal, and anthropogenic space. This is precisely why liberal arts becomes indispensable. Liberal arts encompasses subjects such as history, economics, philosophy, pol science, communication, ethics, and cultural studies, among others. These fields understand human behavior, societal values, governance, and decision-making. In the context of UDA, they complement science and engineering by addressing questions that technology alone cannot answer. For example, maritime disputes are often rooted on history and politics rather than just technology. Similarly, marine conservation depends not only on scientific understanding, but also public awareness, policy and governance and policy frameworks, and community participation. Coastal populations possess knowledge, generations of traditional knowledge about the sea, which can significantly contribute to environmental monitoring and sustainable resource management, which we'll see in one of our presentations today. Similarly, legal frameworks governing maritime bodies, maritime boundaries and fisheries, and underwater heritage require expertise in international law and diplomacy. Furthermore, effective underwater security depends on communication and trust between not just governments, but all researchers, fishermen, and local communities. Liberal arts provides the necessary skills for negotiation, conflict resolution, and public engagement. And finally, strategic communication. Similarly, ethical considerations surrounding underwater surveillance, autonomous systems, and marine resources require physical, philosophical, and legal perspectives as well. Recognizing these realities, Maritime Research Center expands marine and maritime studies beyond naval strategy and oceanography to include maritime history, maritime culture, ocean governance, environmental ethics, maritime literature, coastal heritage, policy studies, and strategic communication. By doing this, it promotes ocean literacy across different levels in the society. This also remarkably aligns with our government vision, such as India's Maritime Vision 2020 or the Mahasagar Vision and our blue economic goals. I'll conclude by stating that as oceans become defining strategic space of the 21st century, protecting them requires more than just advanced sensors and artificial intelligence. It requires historical memory, ethical judgment, environmental justice, legal wisdom, cultural understanding, economic insight, and finally, effective communication. With that, I would like to invite Arnab sir and our mentors and participants who will be presenting today. We have 7 presentations lined up, followed by expert interventions. The session will end with my colleague Nisha delivering the concluding remarks. I thank everyone for coming in today. It's truly an honor. Thank you. Arnab, so over to you.
Thank you, Catherine. First of all, I must thank Ambassador Mudgal sir for always supporting us and guiding us through the work that we are doing. And sir, I'm very proud to say that our liberal arts team is equally strong now. I mean, you know all of them, Catherine, Calistine, Nishtha, and now we have young interns also who are working with us and building this liberal arts faculty in our center. And you will see a diverse set of projects. And we also have Shamyak from IIT to present his work on climate change and the impact. I would also like to welcome Rear Admiral Sanjay Dutt, sir, and thank you so much for joining us, sir. We really appreciate you joining us, and we would also like to let you know the kind of work we are doing and seek your guidance. I mean, in the Navy, I've always been in touch with you and getting inputs from you. We would also like to engage you in our efforts to take UDA forward. And as you will see today, we are trying to touch as many different dimensions as possible. I would also like to mention that this year we have 36 interns working with us, 14 in fact from the top 5 IITs, 17 from BITS Pilani, all the 3 campuses, 4 from St. Stephen's. I mean, these are the premier institutes, and we also have Annie from Delhi University working with us. It's a good mix of young interns and fellows working on diverse areas of, and we are also, as we are moving forward along with the interns, we are also discovering the different dimensions of UDA and taking it forward. So I will not take too much time, and I will hand over to Calistine to take the next presentation forward.
Good evening, everyone. I'm Calistine Jude. I'm the head of publications, and I work with the liberal arts team at MRC. And I think over the course of my journey, I've understood that what MRC does when it looks at technologies and the underwater domain awareness, it has also consistently tried to build the importance of it, not just building our capabilities, but also why are we looking into the oceans? Why are we looking into the rivers, oceans? And, answering those questions is where liberal arts would come, because liberal arts perspectives would look at the how, why, what questions rather than the material built or systems that we want to build. So here, this is a small presentation that I made that I've been working on with Arunam. So it's called Building the Blue Sun, where I've just personally, I feel like the UDA, its framework itself is like the blue sun. And just like a sun, it provides energy and it lights up and we can see space. The same way, the underwater ocean, sunlight does not even penetrate more than 200 meters, I believe. How do you see the rest 97% of the ocean? What are the resources and the organisms, and how do we manage it? So here is where I wanted to place the UDA framework as something that illuminates an entire part of the globe that nobody else wants to see or does not know how to see, and its place in the world order, which is why should we even care about this? So firstly, these are just statistical facts. We all know this. 71% of the Earth's surface is water. It's important for biodiversity. A majority of the Earth's animals are on the water. Food security for billions of people. Climate change is controlled by a lot of these ocean currents. Trade and technology runs entirely through ocean, like whether it's through ships, whether it's through internet cables, internet and finance. Every time you do a UPI, Aadhaar authentication request, it has to travel undersea cables. Cultures and livelihoods, institutions and statecraft, and ultimately world order. So I think that's where we want to center whatever we are doing, is that we have to understand that they intersect with a lot of institutions, a lot of things like that. And so here's what we've developed together, which is 5 things of how 5 segments of how we can world. Where does UDA factor in world order, or like in the institutional or the power dynamics of the 21st century? So firstly, as we know politics, we know that ocean politics is the bedrock, with control over maritime choke points, oceanic resources, subsea cables. Now we know that just having an advantage of the air is not something that's going to win a war. We've seen that happen in the Strait Hormuz. And you understand the criticality of a lot of these choke points, that status, and therefore the very nature of the institutions that are built, the collaborations, multilateralism, data sharing, all of these does form an important part of a statecraft or an institution that wants to understand the ocean that literally we're all floating on. Secondly, about economics again, how does the money come in, right? And we understand that a lot of the oceans is where global supply chains intersect, 80% of global trade. So what we want to do is not just list the facts, but how is this better? Like when you have a ship coming into a port in India, how can you make sure that biofouling of the ship is done better? How can you make sure that the ports are dredged more systematically? How can you make sure that the cables are safe so that nothing happens to international financial systems? So these are something that we need to analyze the questions. So instead of only focusing on how to get it done, we're also going to look at why should we get this done? Why is it important? So that's where a lot of this world order and liberal arts perspective of UDA comes in. Third, again, environment, ecological collapse is existential. All of these spaces we know are getting commercialized. But what we also have seen is that not only is the oceans getting over harvested, but it's also regenerating at larger. Like it'll take decades for a forest to grow back. But the same thing is not the same with the oceans, where reefs can, grow biodiversity. And this is not just good for the nature as something, it's also good for the communities that rely on the food that these ecosystems bring in. And again, demography. We have 50% of the world's population lives within 100 miles of a coastline. Majority of the world's population will live in coastlines. And how do we make sure, like, okay, we're saying people live there near the oceans, but ultimately this comes down to skilling, to capacity building, employment generation, and not just using the ocean as a peripheral, oh, we can't see it, so we don't have to think about it, but as a space where that can on land while building a connection that we have in or underwater spaces, including rivers and lakes as well. And fifth, technology. This is something that we've all seen. Technology, we understand that technology is important because it allows us to see the ocean, it allows us to map. And if you look at the bottom left, that's data centers. So if we want the entire future of humanity is currently now, if you look at the stock market, is being betted on artificial intelligence that will revolutionize the world. But ultimately, like all these data centers require water. Do we have enough drinking water that we're going to divert from villages, or do we think about solutions like keeping them underwater, using the ocean itself as a sink to kind of cool off the servers? And how else can we look at all of these? So we also believe that technology is not like a abstract thing that we can just build because we have to, but how and what should it be built is something that Ekta after me will present as well, and which is talking about what are our priorities. And that's where the UDA framework acts like a sun. It's saying that we're going to unlock energy potential, we're going to be able to see underwater spaces that we can't see before, and we're going to have to get our priorities in check. A structured, comprehensive, and inclusive priority approach where you have digital information transformation, you have strategic security to look at the maritime choke points, you have climate change and offshore wind production, and all of this is a lot of things. It's spread out. It's a very big endeavor, but we need to have a framework to see it and to analyze what is its place in the global order. So as 21st century, like we've been on land too long. Now we have to turn into the waters. We've always turned to waters, but like now with an added focus and the added tools and technologies that we've developed on land, and it just represents a whole new horizon, a whole new frontier that India as a country or even the world as a whole can advance to. And all of that is so much more important to be done in a very structured, comprehensive way. And that's what I think the UDA approach would offer. And I think that's what it's also important to not just have the technological and physical building of these institutions and resources, but also the philosophical and the liberal and the sort of like theoretical approaches to why should we pursue this, what do we gain, what are the trade-offs. So that's something that we will have to manage going forward, and it's amazing that MRC has given me an opportunity to be a part of that journey. And I'll wrap this up. It's been 6 minutes, so that's essentially what I wanted to say, and we're going to build this up step by step, how much UDA as a framework is going to influence the world order and change the way that we see the world, because the world will probably never look the same again because we're going to look at it through a new lens. So yeah, that's from my end.
Thank you, Calistine. Thank you for placing how UDA is going to influence the world order. And now moving on, we have our first research presentation by Ms. Ekta. She'll be talking about the global relevance of UDA. Ekta, over to you.
So good afternoon, everyone. I'm Ekta, and I'm an intern at MRC. Today, I'll present my literature survey on the evolution of underwater domain awareness that we usually call UDA. I will discuss how UDA has evolved from a military concept into a very comprehensive framework for sustainable ocean governance, as well as I'll also highlight the major debates in literature and explain how UDA framework has been addressing it. So, in the first slide, we can see what is UDAs, as Calistine as well as Catherine talked about it. UDA basically is to refer how it refers to the ability to monitor and understand as well as manage the activities that are beneath the ocean surface. But now we can also see that UDA has expanded to include environmental monitoring, disaster management, as well as some kind of things into blue economy and marine resource protection. My research argument is about modern UDA should be viewed as an integrated governance framework rather than only an extension of marine domain awareness. So the major debates are, first of all, we'll start with tropic versus the temperate waters. Here we need to see that the need for region-specific technologies. So the modern underwater technologies were designed for the temperate waters in Europe as well as North America. Today, tropical oceans differ in temperature as well as biodiversity and monsoon-driven ocean dynamics. These differences influence underwater sound propagation and reduce the efficiency of the imported sonar systems. Repeated underwater surveys increase operational cost, fuel consumption, as well as the environment impact. The UDA framework promotes the indigenous acoustic model, regional ocean debates, as well as AI-enabled sonar systems that are adapted to the tropical conditions. The message that I want to put in is that local ocean conditions require local developed underwater technologies. Then the second is the product versus the solution. Here I will talk about how technology alone cannot create the awareness, how government often invest in sonar systems, AUVs, ROVs, and underwater sensors. Individual technologies cannot provide complete underwater awareness without integration. The next slide. Effective UDA requires continuous data collection, communication, and real-time analysis. AI machines learning improves detection of submarines, illegal fishing, as well as the environmental changes. The UDA framework encourages shared databases, institutional collaboration, as well as the integrated decision making. The key message that I would say is UDA is connected system and not a simple connection between the different collection of technologies. In the next slide, I will talk about the strategic, talk about how expanding the scope of underwater security should be there. Traditional UDA primarily focuses on the naval surveillance as well as the submarine detection. Modern challenges also include different types of activities such as illegal fishing, marine pollution, habitat degradation, as well as the climate change. Underwater communication cables carry over 95% of the global internet traffic and requires constant protection. The UDA framework, I would say, integrates security with environmental protection, sustainable resources, as well as management, and much more. So UDA helps in protecting the oceans, also protect the economies, ecosystem, as well as human livelihoods. In the next slide, I will talk about how traditional knowledge versus the modern technology. It helps in building the inclusive as well as sustainable UDA. The traditional knowledge is like how the fishermen now also possess a very long-term knowledge about the fish migration, ocean currents, as well as the seasonal weathers. Scientific technologies that provide a large-scale monitoring but cannot fully replace the local experiences. Combining AI with the traditional ecology knowledge improves decision-making. As you can see, the MRC field work that has been done in the pictures right there. Okay, so in the next slide, I'll talk about how many developed world versus the global south. Many developing countries depend on imported underwater technologies. So the technologies basically depend the technology that are very limited for some certain countries. These technology are indigenous innovations as well as the scientific capacity. The UDA framework here promotes affordable technologies, education, as well as regional partnerships and local researches. Here, the UDA framework values the traditional ecological knowledge alongside with the scientific research. It also addresses the technological gap between the developed as well as developing countries by encouraging the local innovation as well as the capacity building. The next slide, the UDA framework. Here we can see there are the 4 pillars of UDA. First, the security, blue economy, environment and disaster management, and the last, the science and technology. Then the key technologies, artificial intelligence and the machine learning, autonomous and remotely operated vehicles, underwater sensor learning, GIS and digital twins, underwater communication system, and satellite observations. Here, there are also many stakeholders there. The UDA framework is central contribution in the recent literature. Instead of treating these sectors separately, it integrates security, economy, development, environmental protection, and scientific researches through collaboration among the multiple stakeholders. These basic stakeholders are the government, defense, industry, academia, regulator, and the coastal communities that are working together to ensure the maritime security, sustainable development, and ocean governance. Then, in the 8th slide, we can see the framework of the UDA framework cube that was explained by Calistine himself. It shows it explains the 4 important areas: the strategic security, blue economy, sustainability, and climate change, as well as the digital transformation. At the center are the sensing, analysis, and the regulations, which help to collect, study, and manage the underwater information. Together, these support better ocean security, sustainable use of marine resources, environmental protection, and improved decision making. At the end, I would say there are the UDA has one of the key findings, as well as also guides us to the future direction to continue it. UDA has evolved from a defense concept that is focused and connects us to multidisciplinary governance frameworks. We can also say that the future of underwater domain awareness depends not only on the advanced technology, but also on collaborations, indigenous informations, and sustainable ocean governance. Thank you.
Thank you, Ekta. Thank you so much. Now we move on to the next presentation by Mr. Samyak Kumar. He'll be talking about the marine heat waves and its drivers in predictability. Samyak, over to you.
Good evening, everyone. Samyak Kumar. I'm a final year student pursuing my BTech in Naval Architecture and Ocean Engineering at IIT Madras. I'm currently a summer intern at the Maritime Research Center. My internship project is titled Marine Heatwave Drivers, Predictability, and Fisheries Impact in the Bay of Bengal. The primary objective of my project is to understand the environmental drivers responsible for marine heatwave formation in the Bay of Bengal. Once these drivers are identified, the long-term goal is to develop a prediction framework that can eventually support fisheries and climate-related decision making. So before we even go into the project, let's first understand what a marine heatwave actually is. Marine heat waves are prolonged duration in which the sea surface temperature remains significantly warmer than the long-term average for at least 5 consecutive days. In simpler terms, they are similar to heat waves over land, except that they occur in the ocean. Over the last few decades, the frequency, duration, and the intensity of the marine heat waves have increased considerably. One of the major factors is global climatic change, which has caused the average ocean temperature itself to increase. Because marine heat waves influence both the ocean and the atmosphere, understanding their formation is not only an oceanographic problem, but also a climate science problem. The outcome of this project are relevant to several stakeholders, one of the major stakeholders being the fisheries and the aquaculture sector. Marine heat waves can cause fish to migrate to cooler waters, change their distribution, and reduce fish availability in traditional fishing grounds. If these events are predicted in advance, fisheries can better plan their operation and reduce economic losses. Climate and weather agencies can use this information to improve monitoring and forecasting of ocean conditions. Environmental agencies can identify vulnerable marine ecosystems and plan researchers can be benefited by this work as this work contributes to a better understanding of ocean and atmosphere interactions, while policymakers can use these findings to support climate adaptation strategies and sustainable management of marine resources. Ultimately, if marine heat waves can be predicted with reasonable accuracy, decisions are made proactively. A review of existing literature shows that several environmental parameters are believed to influence marine heat waves. These include local parameters such as wind speed and surface heat fluxes, as well as a large-scale climate phenomena such as ENSO, the Indian Ocean Dipole, and the BSISO. The challenge is that different studies often identify different major drivers. Some suggest wind plays a major role, while others say that the heat flux. Another limitation is that many studies analyze only 1 or 2 parameters at a time. This makes it difficult to compare the relative importance of different drivers within a single framework. In addition, the Bay of Bengal is not a homogeneous basin. The northern, the central, and the southern regions have different oceanographic characteristics and are influenced by different atmospheric processes. Therefore, analyzing the entire basin as a single region may hide important regional differences. The objective of this project is therefore to build a comprehensive framework that analyzes multiple environmental drivers together and identify which one of them are strongly associated with the marine heatwave formation in different parts of the Bay of Bengal. To achieve this objective, I've adopted the following framework. The first step was collecting all the required data sets. Sea surface temperature forms the foundation of this work because marine heat waves are identified based on SST. Along with SST, I also collected the environmental data sets, which are wind speed and the surface heat flux. Once SST was collected, marine heat waves were detected using the Hobbs definition, which is internationally accepted standard for identifying marine heat wave events. To better understand regional variability, Bengal was divided into 3 regions, north, central, and south. After identifying the marine heatwave events, I analyzed how each environmental parameter behaved before and during the marine heatwave event. By comparing these parameters with the detected marine heatwaves, we can identify which environmental factors are most strongly associated with the occurrence. Using the methodology I just described, I've completed the first major phase of the project. I processed 20 years of SST data covering the period of 2006 to 2025. Using the Hobbs definition, I identified a total of 117 marine heatwave events across the Bay of Bengal. Using the analysis completed so far, a few interesting observations have emerged. The most significant result obtained so far from the wind analysis. Across all the marine heatwave events analyzed, approximately 80% of the marine heatwaves were occurred during weaker than normal wind conditions. This result is also physically consistent with our understanding of ocean process. Under normal conditions, wind promotes vertical mixing between the warm surface layer and the cooler water below. When the wind speed decreases, the mixing becomes weaker, allowing the warm surface layer to retain more heat. This creates a favorable condition for the marine heatwave development. In addition to wind, I also analyzed the latent heat flux and sensible heat flux. These heat fluxes do change during the marine heatwave event, but unlike wind, their behavior varies from region to region. Some marine heatwaves are associated with reduced heat loss, while others show enhanced heat loss. Therefore, based on the current analysis, heat fluxes do not exhibit as clear or consistent relationship with marine heatwave occurrence as wind speed. The next stage of the project will focus on analyzing large-scale climate drivers. After completing the analysis of the indices mentioned, the next objective will be to combine all of the local and large-scale drivers to determine which combinations are more strongly associated with the marine heatwave formation. Finally, these environmental parameters will be used as input to a machine learning model for marine heat. In the longer term, the prediction framework can also be extended to investigate potential impacts on fisheries and marine ecosystems. That's it from my side. Thank you all for your time.
Thank you so much, Samyak. Now we have our next presenter, Ms. Annie, on decolonizing underwater domain awareness. Annie, over to you.
Good afternoon, everyone. I am Annie Pruthi. I'm working as a research intern at Maritime Research Center, and I am a research fellow at Parliament of India. I'm also a PhD scholar at Department of Political Science, University of Delhi. Here, over the past few months, I have been working on rethinking underwater domain awareness through the lens of decolonization and looking at tropical maritime realities through community-derived knowledge systems. In today's presentation, I will be briefly discussing the research gap that I have identified over the past 2 months and the work I have undertaken at MRC and what is the broader research direction that we can carry our work forward. So, before I discuss my research, I would like to explain why I believe UDA needs to be viewed from the decolonial lens in the first place. So, what do I mean by decolonization? By decolonization, I simply mean to address the epistemic injustice. What is epistemic injustice? When some forms of knowledge are considered more legitimate than others. So I have identified 4 key gaps in the existing framework and the discourse that we have. First and the foremost is that many frameworks are informed by Eurocentric maritime experiences, whereas the Indian Ocean is a tropical maritime region. It is shaped by monsoons, by diverse coral reefs, and strong coastal dependence. Secondly, UDA primarily relies on technological surveillance, while knowledge generated by coastal communities through generations of interaction with the sea is totally underutilized. Third, universal governance models often overlook context-specific ecological intelligence that is very unique to the local marine environments. And finally, UDA remains very state-centric because it is based on security, whereas coastal communities are not considered to be legitimate knowledge producers. So my research therefore argues that we need to decolonize UDA, and it is not just about replacing technology. I'm not at all talking about replacing technology. What I'm talking about is to recognize the multiple ways of understanding the underwater domain through a very inclusive and community-centric approach. Now, after I have identified the broader epistemic gap that we have, I wanted to understand where this gap actually is coming from. So, through my research, I found out that one of the most important reasons is that many existing UDA frameworks are informed by Eurocentric maritime experiences and technologically driven models of surveillance. So, in other words, what happens is that these developed models that we have today have been developed from the experiences of temperate regions, as Ekta talked about in her previous presentation, and the tropical realities are completely ignored. So, the Indian Ocean region presents a very different reality, which is characterized by monsoon-driven circulation, shallow continental shelves, coral reef ecosystems, and rich marine biodiversity. So, this means that the underwater challenges in tropical waters cannot be understood with the one-fit-all approach that we have. And my research is basically arguing that Indian Ocean should be understood as a distinct strategic and ecological space. By localizing UDA, that is, by making sure that we ground it in environmental and operational realities of tropical waters, we can therefore develop approaches to underwater awareness that are context-specific, inclusive, and better suited to the region. Now, the other question that my research points out is that if tropical realities have been so underrepresented, have the knowledge systems not evolved, or are there no knowledge systems at all to address these questions that we have? So, as we explore the tropical maritime realities, the next question was, who has understood these environments most intimately over centuries? The answer is very obvious. It is the coastal communities, because they have been living in these areas around the coast, and they have been working with waters across generations. However, this is the epistemic blind spot that I have found out. So, despite centuries of continuous interaction with the marine environment, indigenous and community-derived maritime knowledge has largely remained very peripheral. And even if it has been talked about, it has been talked about in a very anecdotal sense. So, my research challenges this assumption, and I argue that these are not simply traditional practices, and it is not okay that we categorize it as traditional practices. They are maritime epistemologies. That is, they're very systematic ways of knowing and understanding the underwater environment. This is the process that I have tried to conceptualize here. If you can see the this top down, the approach that I have looked upon, it begins with continuous observation of the marine environment. Over time, these observations, they develop into environmental sensing. Then they become social memory. So, mind you, this is not individual memory. This is social memory collectively formed. And for this, we need a lot of ethnographic studies. Then it becomes maritime cognition. And this is how community governance gets evolved, which basically contributes in underwater awareness. To illustrate this, my research is focusing on few case studies. I have picked up the Mukuvar communities from Kerala and Tamil Nadu. I have picked up the conceptual framings of Kanicham and Kadakodi that again comes from the Malayalam language. And then I have also done a comparative analysis with the pearl driving traditions that are embodied in the West Asian region, especially in the Red Sea region. So, the contribution of my research is to reposition these community practices as legitimate systems of maritime knowledge. Rather than viewing them as supplementary to technology, I argue that they generate localized ecological intelligence, and they can complement contemporary approaches to underwater domain awareness. The final stage of my research is moving from identifying the problem to proposing a framework that addresses it. Throughout this presentation, I have been talking about, how the challenge is not the absence of knowledge, but the unequal representation of this knowledge. This is what I refer to as epistemic injustice. It is basically a decolonial term used by decolonial thinkers, where they talk about how technological and dominant Western-based knowledge systems have often been privileged, while tropical experiences and community-derived knowledge systems have been receiving very less recognition. So my research therefore argues that what the solution is to to move towards epistemic pluralism. Again, we do not have to necessarily, replace the technologically derived systems. We have to make sure that technology is one way to understand underwater domain, but community knowledge is also another and legitimate way through which we can understand the underwater domain awareness and gain ecological intelligence. This is where the idea of knowledge co-production becomes very important. So instead of relying exclusively on technological systems or exclusively even on community knowledge, I propose we bring these two systems together. Modern technologies, of course, matter, like sonar, underwater sensors. They provide us the precision that is required. But coastal communities contribute towards detailed and context-specific ecological intelligence that comes from generations of experience that might not come from scientific surveys. So the outcome of this research is that I describe a tropical and community-centric framework for underwater domain awareness, which recognizes that tropical waters have very distinct environmental realities and that coastal communities are legitimate producers of maritime knowledge. My contribution is divided into three themes. First is the theoretical contribution I'm making. Second is the methodological contribution. And the third one is the institutional contribution. So the first theoretical perspective is my research introduces a new maritime epistemology as a conceptual lens for understanding underwater domain awareness, which repositions the Indian Ocean as a very distinct tropical strategic space and talks about and contributes to the ongoing debates on epistemic justice, knowledge pluralism, and the localization of maritime governance. Methodologically, this work brings together historical inquiry, indigenous knowledge systems, and maritime governance with a single analytical framework. In fact, I told you that there is a lot of scope of ethnographic studies. We can embed ourselves in the communities that have been working across generations in these coastal communities and learn from them. Institutionally, I believe that this research opens a new and distinctive trajectory within MRC by foregrounding decolonized, tropical, and community-centric approaches to underwater domain awareness. It also creates opportunities for future research, publications, and interdisciplinary collaborations. Ultimately, my objective has simply been to study communities or tropical waters, but to contribute a new way of thinking altogether about UDA. One that is, of course, technologically informed, but also epistemically inclusive and grounded in the realities of the Indian Ocean. And I hope that this research can serve as a foundation for expanding MRC scholarship on community-centric and tropical approaches to underwater domain awareness. Thank you so much, and I look forward to the feedback.
Thank you so much, Annie. We'll move on to our next presenter. Our next presenter is Mr. Vaibhav Sachin. He'll be talking about modeling and simulation-driven MSP. Vaibhav, over to you.
So I'll be talking about something called the modeling and simulation-driven marine spatial planning. This presentation will be covered under these ambits. I'll introduce my abstract. I'll give a little bit of a background context. I'll tell you what the problem with marine spatial planning is. I'll tell you where my intervention comes in. I'll explain it, and I'll do a little bit of a stakeholder analysis. Right. So as far as my abstract is concerned, what I am basically looking at is that traditional marine spatial planning, it is largely descriptive in nature and it is very governance oriented. All that, sure, it exists. But the problem is that it is not able to forecast any kind of a planning consequence. Why? Because it heavily relies on existing data. It heavily relies on data which is very much static in nature. So what I'm attempting to do in my project, in my research, is to examine this critique, especially in the Indian context, largely because the Indian Ocean water, it's very much different from the Western waters. The place of origin of marine spatial planning has largely been the Western waters in the Western countries. For instance, if you think of the ways in which the Pacific Ocean and the Indian Ocean, they're different, you have a lot of ways in which there is a lot of dynamic elements involved in the Indian Ocean that are not there in Pacific Ocean. Therefore, the argument is that this architecture of marine spatial planning is structurally not suited to India's monsoon-driven variability, ministry-level data fragmentation, and the absence of a unified MSP authority. And therefore, we must resort to something called the modeling and simulation-based MSP. To give you a little bit of a context, the Indian Ocean region, it faces two very complex issues. One is that it is highly variable when it comes to its oceanographic and atmospheric processes. So for instance, you think of the Indian Ocean dipole, you think of the Madden-Julian oscillation, the ways in which the temperature fluctuations happen in the Indian Ocean, particularly because it is situated in that part of the global sort of domain. And also, there is a lot of complex and geopolitical maritime activity. So you think of the epicenter, such as the Strait of Hormuz, the Strait of Malacca. With the Indian context, you have the Gulf of Khambat, the Gulf of Mannar, etc., etc. So it becomes a very it becomes a hot seat of a lot of complex geopolitical and trading activities, which are very dynamic in nature. Now, the existing literature that exists on MSP, which by the way is on traditional MSP, it comes with a whole lot of problems. So you have three major articles that I have looked at. One is an article by Ehler and Doover, the other is an article by Portman, and the third is an article by Grip and Blomqvist. So Ehler and Doover, they're talking about a very integrated approach of marine spatial planning. Portman is giving a very step-by-step approach of marine spatial planning, and Grip and Blomqvist, they're also giving their reviews on existing traditional marine spatial planning. But one common critique, which is, by the way, common to all of these papers and all of this research, is that it is highly dependent upon static and governance-oriented data, a data which doesn't change over a period of time, but that doesn't and cannot suit the Indian Ocean. So four limitations occur across this. One is that all these conventional plans, they are built from static spatial data sets, and they represent a single point in time and not a period of time. And even though they might talk about species distribution, fish stocks, oceanographic conditions, one needs to understand that these are very inherently dynamic conditions. Second, traditional MSP, it can only identify existing conflicts among marine users and stakeholders. It cannot forecast long-term consequences of, let's say, upcoming conflicts or upcoming changes in the geomorphology, etc., etc. Third, sectors such as, let's say, fisheries or shipping or tourism, conservation, or let's say coastal infrastructure, these are very interconnected. These are very interconnected structures. These are very interconnected issues. They don't exist in isolation. And further in my in my presentation, I'll be talking about it, how they are very cumulative in nature. They're very interconnected in nature. This is something that traditional MSP cannot deal with, which is exactly why we need an MNS-based MSP. Lastly, conventional frameworks, they rely, like I told you about, on current observations, on expert judgment of static data, and not something which is dynamic in nature. And this, by the way, is not very theoretical in nature. It is very much grounded in reality. So for instance, in Tamil Nadu, they had built up sea walls that were constructed to manage coastal erosion without any kind of modeling that was done on how sedimentation works and how sediment transport dynamics work. The result of it was that the entire erosion, it became downstream, and the fishing hamlets and the turtle nests, they were damaged. For instance, in Kerala, a $900 million infrastructure was totally stalled by a community because their views and their traditional knowledge, the indigenous knowledge that existed about them knowing about how things are forecasted, that wasn't taken into account. So they had to halt an entire $900 million infrastructure project. So you see, it's a tremendous waste of time and energy and resources, particularly for a developing country like India. Okay, now I'll explain how MNS-MSP works. It works through this 5-channel situation. One, the first gateway that it crosses is real-time and historical data streams. So you think of oceanographic data, you think of biodiversity data, you think of human activity, you think of infrastructure. All these channels are taken care of. Second, it goes to simulation engines. So you model it, you simulate it. So for instance, you think of hydrodynamic simulation, agent-based simulation, climate projection, how climate will look like eventually, how an ecosystem will look like eventually. Third, it goes through impact analysis and scenario testing. So you can think of habitat risk management, you think of acoustic impact, you think of cumulative stress of all of these sort of areas together, you think of the conflict between different interest holders. Then it goes through decision support interface, where you have, let's say, the GIS dashboard, or for instance, you have policy tools that sort of help us in understanding and analyzing it. You have adaptive feedback. So whatever feedback comes in, you inculcate it into it. Finally, it comes into a simulation-based adaptive MSP plan, which is the final outcome of it, which is a very much of a living plan. It is continuously updated because the feedback that is coming in is also being updated. Therefore, it is very much in action. It is very much full of life. Okay, so there's a 6-initiative toolkit that I have brought in front of you. I won't go into
individual depths, but I'll probably talk about, let's say, I'll talk about underwater noise mapping. So what the sixth initiative toolkit essentially is, it is about the 6 different areas, especially where MNS-based MSP can be used. So for instance, for underwater noise mapping models, you have various sources of noise. So you have the wind, you have the rain, you have the shipping driven acoustic sort of contributions. All of these, they are mapped out in a cumulative stress map that supports seasonal climatology and the identification of acoustic quieter windows where sonars can be operated. Now, this wouldn't be possible if you're using traditional MSP, because it cannot predict how wind will flow. It cannot predict how rain will sort of, give its noise in the upcoming areas. So in order for you to have fully operational sonars, you require a prediction, you require a forecasting, where MNS-based MSP comes handy. Lastly, I have the sectoral implementation and stakeholder analysis for you. What are the various places and areas and fields where you can possibly use this MNS-based MSP? So you have fisheries and aquaculture, you have shipping, navigation, and port infrastructure, you have offshore renewable energy sitting, you have hydrocarbon and sea-based mineral extraction, coastal and marine tourism, disaster risk reduction, marine conservation, and eventually we have maritime domain awareness, something that we all have been talking about. It's all very interconnected, it's all very sort of interlinked, and therefore MNS-based MSP proves to be much more fruitful in helping us navigate and understand through this. That's all. Thank you for your time.
Thank you so much, Vaibhav. Our next presenter, and he'll be talking on sector-specific analysis for simulation-driven MSP in the ports of Maharashtra when it comes to blue economy assessment.
Good evening, everyone. My name is Peter Bichu, and I'm one of the research interns at MRC. So the aim of the project that I'm covering is to be able to create a comprehensive blue economy accounting framework covering various important aspects, not only just for an accounting perspective, but to be able to actively integrate it into marine spatial planning for policymaking. So to build the base for such a framework, my project in particular covers the state of Maharashtra as a pilot state, and we are going to be looking at 3 particular sectors as a foundation for the framework, with the long-term objective of being able to apply a similar framework to other states according to their specific context, and also be more inclusive by including other economic sectors into the accounting framework as well. So why do we need an accounting framework in the first place? So conventional accounting often misses a lot of important aspects, especially when we come to an environmental or social perspective. Conventional accounting often misses out on a lot of important aspects like environmental degradation, services provided by the ecosystem, strategic and security value of the ocean infrastructure, as well as dominance with latent ecological value. And our framework plans to cover all of these aspects as well. Some factors. So the 3 sectors of Maharashtra, particularly looking at, are ports, fisheries, and mangroves. My presentation will talk further on the research that I have done on ports. Ports and fisheries are obviously 2 very important pillars of a blue economy. Mangroves isn't, strictly speaking, however, we plan to include it to incorporate the environmental perspective, especially for a state like Maharashtra, where mangrove conservation is a very important topic that needs to be given priority. And finally, obviously, we talk about integrating all of this into our marine spatial planning tool, which is really important for converting accounting into tangible actions by identifying possible conflicts that are there between different sectors, locate possible opportunities and costs, guide policy making, and be able to prioritize restoration investment. So this is the identity that we build upon when we are building a framework for the blue economy. We obviously cover aspects like the market value. On top of that, we cover environmental aspects like environmental degradation and restoration costs. We include the services which are offered by the ecosystem, as well as other kinds of opportunity cost and strategic value. Yeah, so the port sector is an important aspect when it comes to Maharashtra's blue economy, specifically. The Jawaharlal Nehru Port Authority, which is one of the two major ports in the state, it itself handles approximately 65% of India's total throughput. There are over 50 minor ports operated by the Maharashtra Maritime Board, and a large portion of the investment from the Sagamala program is for the port sector in Maharashtra. So applying the identity that we talked about specifically to the port sector, we are able to map a lot of different variables to each of these parameters. Firstly, we have market value, where we cover all the income aspects, the various sources of income from the port sector, when it can be vessel charges, cargo charges, and other forms of income as well. We also try to incorporate indirect costs and incomes through input-output multiplier analysis and logistics cost savings. We also acknowledge the importance of avoided cost value. For example, the saving of costs, the cost savings that we get from using coastal shipping as a substitute to road freight, the savings that we get from efficient turnaround when it comes to emissions. We also include other aspects the effects of leaching from anti-fouling coatings, as well as positive environmental effects like afforestation, spoil disposal, and shore protection. Strategic value is also another important aspect. It is obviously hard to quantify, but its importance needs to be acknowledged. And similarly, ecosystem service value is another important aspect, where we cover mangrove, seagrass, and tidal ecosystem services and their contribution to the blue economy. So the findings from my analysis of ports in Maharashtra, firstly, by assigning every category to a specific term in the identity with a predefined valuation method and a confidence interval, we are, at least to a certain extent, able to convert the qualitative environmental concern into a structured and quantitative sustainability accounting framework. On a similar note, we see that a lot of the substantial costs are often entirely ignored, and data is very partial for these aspects. Variables like the destruction of mangroves and the displacement of fishermen are externalities that are often omitted in current port economics. Also, when we look at the Vadhvan port, which is under construction, it serves as an important case study where we see whether India is willing and able to move from growth-focused accounting to generally integrated ocean value accounting. And lastly, we need to acknowledge the fact that UDA isn't a separate subject from the blue economy accounting, but it serves as a framework for reliable and useful data that makes BA as comprehensive as possible. And obviously, this isn't the first time that an attempt has been made to include a sustainability focused blue economy accounting framework. And there are a lot of limitations and obstacles that we face when we come to this. First is obviously, as I mentioned before, the absence of data and the availability of only partial data. Ports factor, we see that a lot of the income data is missing for ports in Maharashtra. We also see the aspects like underwater radiated and avoided cost value. We also are not able to count for cross-boundary externalities when we are strictly talking about state-specific analysis. Also, we are not able to capture equity and distributional impacts clearly. For example, social and gender dimensions are acknowledged as important, but since they are very qualitative in nature, it's very hard to capture that into the identity itself. So finally, we plan to kind of replace the question, how much does the ocean produce, with how much sustainable ocean value is produced, preserved, and secured. And by undertaking the sector-specific analysis for Maharashtra, we are able to build a baseline for its framework, with the long-term objective of being able to scale it up further. And like I mentioned before, UDA is not a parallel system. It's a real-time data infrastructure that will be able to make accurate and updatable BAA possible. Thank you.
Thank you so much, Peter. We'll move on to our next presentation by Ms. Anvi. She'll be presenting on hull biofouling management. Anvi, over to you.
Good evening, everyone. I am Anvi Mishra, and I am a second-year undergraduate student pursuing Masters in Economics and Bachelor's in Electrical and Electronics Engineering from BITS Pilani, Hyderabad campus. And today I'm going to be talking about my research work that is centered around quantifying the biofouling risks for Vadhvan port. Now, Vadhvan port is a huge economic asset. It's a huge greenfield mega infrastructure that at its full capacity is projected to have around 298 million tons per annum capacity, and this represents a huge economic engine for global and local trade networks. However, the strategic objective extends far beyond just some simple cargo capacity. Now, Vadhvan is um, attempting to be a ESG focused green hub, which requires proactive risk management and even more to protect both the operational velocity and the regional ecosystem. Now, the primary invisible vulnerability the port faces is marine biofouling, which acts as a hidden tax undermining vessel turnaround times. The hull accumulation severely increases hydrodynamic drag that impacts the performance and efficiency of 24,000 TEU container vessels that the Vadhvan port is supposed to accommodate. Now this drag translates directly into lower transit times, excess fuel consumption, and disrupted port scheduling. Furthermore, the dislodged biological matter introduces several infrastructural risks to the critical static port assets and the nearby water ecosystem and infrastructure. Now, to address this bottleneck, my core analytical contribution is the applied ALM framework. Now, the asset liability matrix basically takes these complex marine physics and the biological ecosystem into account and converts it into a structured 20-factor matrix spanning across economic, environmental, and social pillars. Now, by classifying them into these tangible assets and liabilities, it provides the stakeholders with a clear, measurable framework to evaluate the true costs of biofouling. Now, let's say for environmental factors, we can say that the dislodged debris is one of the biological impacts. Let's if we say social, it could be the livelihoods that get misplaced because of the construction of a port, and for economic, it can be the excess fuel burned or the CO2 liability. Now, the matrix, I have populated the matrix with some precise hydrodynamic modeling to help us quantify the penalties. Now here you can see Towson's frictional resistance formula, and it basically tells us the added. It basically tells us the added coefficient of friction due to biofouling. Now, the methodological approach is grounded in three clear operational pillars. First is scenario modeling. So, basically, using advanced hydrodynamic principles, I've reached a conclusion that there's a 73.7% increase in total vessel resistance under heavy macrofouling. And secondly, is baseline calibration. So, what I've done is basically I have customized all the calculations to the real world scenario that will be a 24,000 TEU ship, which matches the Vadhvan's 20-meter draft perfectly. And third is I have analyzed the acute liabilities, explicitly spotlighting the severe operational risk of dislodged debris clogging the cooling water intakes at the adjacent Tarapur Atomic Power Station. Now, this atomic power station is just 15 kilometers away from the proposed location of Vadhvan port. And because of its proximity, if the dislodged biological debris can actually reach the cooling water intake infrastructure, and through some calculations I have figured that that the debris will actually be alive and can actually really seriously affect the infrastructure. Now, this data brings us to a stark financial imperative. Now, biofouling transcends just basic environmental and ecological compliance. It is a severe, calculable economic drain as well. Now, the model demonstrates that a fouled vessel trying to maintain its service, industry standard service speed, incurs a massive fuel consumption penalty. Now, this equates to an excess operational cost of 4.16 lakhs per hour per vessel for transit. Now, this inefficiency directly erodes carrier profits and restricts the aggregate port through output. Lastly, the way forward is applied financial modeling. So firstly, what I can do is develop the asset liability matrix, and to evaluate the broader economic impact of hull biofouling on Vadhvan port operations. Second is liability forecasting, which is basically taking these physical and environmental risks that are quite difficult to quantify and making them into quantifiable financial forecasts. And thirdly, what can be done is assessing the economic feasibility and the potential ROI for future preventive management strategies at the port. And this concludes my presentation. Thank you, everyone.
Thank you, Anvi. We conclude all the presentations by our research fellows and interns. We'll now move on to the expert interventions. I'd like to invite Rear Admiral Sanjay Dutt for his comments and feedback on the presentations.
So, good evening, everybody. Ambassador Mudgal, Ambassador Tariq Karim, Commander Arnab Das, and I think all the fantastic people at MRC and the interns. To be honest with you, this is more being an operational kind of a guy. Liberal arts and UDA, this is a very exciting prospect. And I think each and every of the researchers has done the due diligence to at least get into it. Of course, it's a growing field and progressive. If you allow me, I'll probably note it down some things for each of the presentations, just my views. They may probably in this whatever little time I could grasp of what the researchers have been doing. If I start with building the blue sun, I think one thing I must say that it's a very short, evocative, and carries the idea of illumination, guidance, and the life of the UDA. So that quantifies it all, that why it is an important thing. And I think what has been said is very important. And I think the research brings it out all on that. As far as the global relevance of UDA is concerned, I mean, before I go on to it, the view I took, or I would just like to submit, is that having been here at the College of Defense Management and being party to a lot of research, one of the things that I think most researchers should be careful of is not to situate the appreciation, in the sense that not take into account that this is the ultimate goal I want and then work backwards. So that what happens is then that research does not become original. You're trying to fit something into something. I'll come to it in probably some of the presentations. I did feel that, But just take care of that, because you all are doing some fantastic work, and it's original. It's actually original. There's not much information about it, so it must not only sound but appear also original. So just be careful of not situating the appreciation, as we call it in the armed forces, that I know I have to win that, so I assume that everything down the line will be there. So coming to this presentation on the global relevance of UDA, I think what I could make out is that the central hypothesis of this particular presentation would be that the world's ocean are increasingly becoming interconnected through this climate change, geopolitics, subsea infra, blue economy, etc. and all. And I think the presentation was on the right track. But what is that we must answer the question is that what makes UDA globally relevant? Is it UDA or is it MDA? Because this is another parallel term, maritime domain awareness. Does UDA become a subset of maritime domain awareness or what? So that is one thing that we must probably make a distinction. And rather than simply describing each country, I think it is important that we must take into account the work that has already been done and not be dismissive about it. So that rather a comparison, because this comparison can help us maybe make a global UDA maturity model, wherein we could identify level 1, which is a basic model that we are talking about, level 2, which could be at a national level, level 3 could be integrated one, level 4 could be getting AI into it somehow, and of course level 5 will be a global cooperative model wherein multiple UDA frameworks can work together. So this is something that could perhaps be a thought process, and maybe because work is being done here, this could also form the basis of identifying what is the global UDA readiness index. That means that where do I stand? Where does XYZ stand? So that will obviously keep the ball rolling and keep everybody on their toes, that they need to achieve that kind of an index. It is not to say that, it's not from the political part of it, but fact is that, we would like to obviously learn something good. And if we are down on the index rankings, maybe there is scope for us to come up and reach that level. And of course, one thing, I am not sure, maybe I could be wrong, but there is, I read somewhere that there is a sustainable development goal, which is about life underwater. Is there. So maybe what is the relevance of UDA that we are talking, and how does it map onto that? So I think this global relevance of UDA is very important, because this obviously gives us a start point of how and where do we go forward. As far as the marine heat waves thing was concerned, I think, I mean, when I read that paper, it's a very highly scientific. It's got a high scientific potential, and I think I was glad that. But though I noted down something, but I'm glad that the presenter, sorry, I think it was Samyak gave the thing about how he wants to move to a predictive model, and I'm glad that that part is there, because instead of working on just like a descriptive view that I've got this SST data, I've got this data, that data, how do I put that together in a framework? And this, maybe I'm saying it now, but this is actually related to the subsequent thing which is coming up. So, I mean, this could perhaps be a digital twin of the Bay of Bengal. And, we could have a digital twin of the IOR, which is that MSP, which turns out. So that means that anything and everything is, is both qualitative and quantitatively correct. So I think that had a very high scientific potential, and it would be worth seeing. The only thing that I probably wanted to just question was that when we talk about the intensity, the marine heat wave intensity, is it we are talking about increasing, or is it talking about the frequency? Because if we talk about Bay of Bengal, there are a lot of things which keep happening from Bay of Bengal, including cyclones and all. I personally have been I'm a witness hudud when it came to and hit Vizag. So, and nobody, this thing. So there are a lot of things out there. I don't know the correlation, so pardon my ignorance on that. But I thought that this could be, and there. And what is the driver? The driver is climate. The driver is the monsoon, or driver is maybe the tropical conditions, or something like that. But I think I was glad to hear that the framework is being developed, and some part has been done on that. So kudos to that part. Coming to decolonizing of UDA, I think this was Miss Annie presented it. So I presume, now this is probably, you could correct me in that, when you suggested that there was an epistemistic injustice, it appeared to me that you are trying to situate the appreciation. However, later on during a presentation, it emerged that you have done a lot of research and come to that conclusion, which is fair enough, and which I think is. And this could become one of the most original papers as far as original, UDL literature is there. But I would also like to urge that we don't say remove Western science and assumptions, because you use term, because I would want to ask you, what do you mean by decolonizing? You talked about tech, but that is not only tech, it is governance, it is knowledge, and it is institutions. Whilst tech was not there with us. So obviously we didn't develop any kind of a framework at that point in time. And are there any institutions out here? Yes, there are, but how well they're integrated or collaborated is a separate question. And whether we have the knowledge, detailed knowledge is the thing. So what I'm trying to say is that let's not remove Western science and assumptions. We know that they were developed primarily for NATO, primarily for the Atlantic, and sonar models. I know Arnab knows it well, that what we tried sonars in Russia, we got fantastic ranges, and we didn't even get half the ranges out here when we came here. And a submarine is right next to our ship, and we are not able to go because the tropical conditions are such. And we would blame it on the sonar, but it was not, because it was not designed for that. So I guess it's a very, very relevant, and maybe perhaps I would recommend that if the case studies, I think you did mention some case studies, but if your study could be grounded in some case studies, it would make it more meaningful. And this could obviously help develop a technical framework for this thing. So one thing is there, that you must clearly bring out, where have the Western assumptions failed, right? Just by not dismiss them, but say that, hey, it failed here, and this is what we need to incorporate for us. So perhaps we will be able to undo that epistemistic injustice that you are talking about. But I think it's a very strong version of this, can become one of the most original papers as far as this thing is concerned. Coming to the marine spatial planning, I think if I understood it correctly, and I think that was relayed highlighted, that we rely on statistics maps. In fact, we should be using digital simulations. So please correct me if my understanding is wrong, but I felt that because I'm a tech guy, computer guy, so I relate to simulation rather than building first and then discussing later. And I think this is a brilliant idea as far as creating a digital version of the EEZ for India. So, and which covers, I presume it covers Bay of Bengal, Arabian Sea, and all. And my only word of caution, that from whatever I could read, is that there is a lot of reference to we propose, we integrate, we model, we simulate. So maybe they can be qualified by probably real, because so that the user gets an idea that it is not just merely English, but and the credibility gap has been covered. And of course, you could use this Vijayangam as an example to say that what was conventional plan predicted and how is a simulation. This could be the ultimate future study. But I think this is one of the excellent papers. And I think you did mention that there was a 900 million loss. But I'm just saying that when we have the simulation in place, And suppose the simulation says that, hey, the fishermen have to be thrown out. Will we take a call on it? Here, in your case, it was done and then it happened. But so these are some of the intangibles that will exist. But I think it's a brilliant and it overlaps with the other things also. As far as the blue economy assessment is concerned by Peter, um, yeah, makes sense that we only restrict the income to infrastructure, services, and other things, and here is the environmental. But my understanding is that when you have relate that equation of yours, is it linear? Is everything linear? Is my question. I mean, everything does it just add up? Because when you say that mangroves are impacted, mangroves must be impacting fisheries, and they must be impacting some other coastal infrastructure, whereas you are taking this into account elsewhere also. So you have to be careful of any double counting, as they say. That means that you should not be adding it here also and there. So your results may be wrong, because if your results inputs are incorrect, your output would also be there. And I think you have done the creating a maybe the way forward could be by creating a dashboard and add scenarios, which is whether it's business as usual, that is a JNPT, or is it a green port, etc., and all that. So I think this is a very promising and original framework which comes. Though I believe you have said that this is already existing. As well as coming to the last one, I would absolutely endorse that this is required. I can give you an example of fast attack crafts, which are very small crafts, speeding at about 42 knots in this thing. And once we realized that its speed was not going beyond 30 knots, and we realized that it was fouled completely. Well, it's a small boat, so you can pick it up with a crane and put it on the jetty, and we found that it's fouled. So this is a real problem. However, for big merchant ships, it doesn't happen when the ship is moving. It happens when the ship is alongside for a long time. So the point is that it can be incorporated, but the idea is that who will pay for it? Is the ship owner going to pay for it? So this must get incorporated in your research. So perhaps what I recommend is that for the 24,000 TEU, I was wondering where did this figure come from, but you have already clarified it. The 24,000 TEU, you could probably do a comparative study and take out the penalties that would be associated with it. So that's all from my side. Sorry, I've just given what I could just quickly make out, but thank you very much for this opportunity to be part of it. Because this is an eye-opener for me also. And thank you, Arnab, and thank you, everybody.
Thank you so much, sir. I think I'll just clarify, it was my mistake also, and probably shortage of time. Sir, we have done, we're working on two parallel things. Marine spatial planning, of course, remains the backbone of the entire UDA framework. And so one is that we have written a MSP handbook, which largely addresses the policy aspect. Mudgal sir is also one of the authors on that, and Catherine is the main author who has put it together. Basically a UDA-driven MSP framework, which largely addresses the from a policy side. But parallelly, led by Sridhar, who's deputy director at MRC, is not here today. Sridhar is driving the actual digital twin platform. So over last 6-7 years, we've been working, and every year we get about 30-35 young interns who contribute. And today was more on the liberal arts side. So each one of them is building up every component. Like if I just talk about biofouling, we have so typically what happens is a intern works for a while, and 2-3 cycles of internship, we develop at a particular domain. So biofouling, now it is in the 3rd round. So we have a research fellow who's been working. So we have separated into 5 stages of biofouling, and also 5 different categories. Like a moving ship platform, like a ship is one aspect, but even the merchant ships have a very clearly defined path, and on the contrary, naval ships have a different, they don't move in uniform speed, and even the areas are variable. So how to model that? and then also looking at the static platforms. I mean, so you will appreciate that fouling in Kochi and fouling in Vizag are totally different.
Yeah,
So
absolutely.
we are trying to model this. So I mean, I could even say that every 100 kilometers the fouling process is completely different. So we are earlier I thought we will go right up to kind of anti-fouling, but I said there is so much work to be done in the modeling itself, or I mean, understanding the fouling process itself. So we have invested significantly in the modeling and simulation of fouling. And these are, I mean, what you heard from Tanvi is a kind of extension to the basic modeling and simulation of biofouling. So they are all contributing to the larger dashboard of MSP. And basically, MSP is digital twin, so which you understand better. So we are trying to build this up across multiple verticals, like sediment management is one big issue, biofouling is one big issue, fisheries is one big issue, aquaculture. So we have research fellows who have been working at least for a couple of years, and then they define, like there are other projects, technical projects on, like in Andaman, what would be the impact of monsoon on the biofouling process. So we have divided multiple projects just in biofouling. I think this time there are 4 or 5 projects, again guided by the research fellow. Similarly, coral, impact on corals, impact on I mean, oil spills. So different factors. And then once this modeling and simulation driven MSP comes in, then you have a digital twin. And
Yeah.
we are also working on gap analysis and position paper. So there it is very, very specific, a geography, like say Konkan coast, we pick up aquaculture, we pick up very specific problem, and what are the impacts on people in terms of livelihood and various other aspects, economy, and also the sustainability angle. And then what kind of policy intervention, technology intervention, capacity building needs to be done. So we are trying to kind of build this up. And Annie is working on this. I mean, I actually was part of a workshop where I talked about the UDA framework. Turin University and Christ University had a joint workshop, and I was invited. So I was among the historians in that group, and they invited me to write this paper. So I took Annie with me, and we are trying to kind of focus on her original paper. She has given a lot of case studies. I mean, different aspects, and we are trying to connect the Red Sea and the Indian Ocean. So different communities, like there are certain communities, pearl diving communities in Red Sea, who I mean, they're far better divers. I mean, you're also diverse, so they're far better divers than most of our people. I mean, because traditionally they have been they have learned something. And how can we document them and also then combine it with the modern science and technology? So, I mean, sir, we are trying to build this up across various dimensions, and we have built the entire data pipeline and whole lot of other things. I mean, even Vaibhav is not a tech student, but he is trying to do the documentation for Sridhar. I mean, the whole framework that we are building. So we are trying to stitch as many.
No, I
dimensions.
think is brilliant, because the liberal arts can actually fuel the tech, like
Yes.
I'm sorry, it just came to my mind that I was speaking to one of the deep tech founders in the US, and he said that and this issue of fouling came up, and he said that there is one firm which we're trying to get in touch with, is that they have developed a kind of a chemical or a paint which prevents fouling altogether, So anyway, I mean, so these kind of researchers can actually fuel what kind of tech also we need. Right. Thank you.
Thank you. Anup sir, over to you.
Thank you, Arna. In fact, I keep talking at your meetings and seminars. And after today's conversation, I was just wondering, what should I say different? Because most of the issues I have been talking about already. In fact, I thank Admiral Dutt for having covered the tangible and technical part of all the presentations. And he has covered them from 360-degree coverage. There is very little for me to add to that. But I will give a very general, philosophical overview of how I look at UDA, nothing new for you, Arnab. We have talked about this very often. You know, for me, when I look at the ocean as our partner, and it's a historic partner. This is not the first time I am going to say that the life originated in ocean, yes, and then evolved over millions of years. And we are the consequence of that evolution. So in a way, ocean is the real mother of life. Yes. But as most of the creatures, as part of the evolution, they understood the role of mother much better than the final product called humanity. Right? We didn't understand how to deal with this immense partner, which not only created us, but has nurtured us, has been there at every step of our growth and progress. And we thought we can take it for granted, and we can do whatever we want. And after so many years of mismanagement or taking it for granted, finally we understood that the ocean is talking back to us. Yes. And given this immense scope and size, we know if the ocean is warning us, it must be something very serious. Yes. So, as a partner, as in all partners, there are opportunities in the partnership and there are risks in that partnership. And when we look at the ocean, we have derived immense opportunities and benefits. Somebody mentioned about blue economy. I have done reports on blue economy. And you look at the food security, energy security, transportation, biotech, energy, renewables. You know, people say that the ocean assets in terms of blue economy could be about $23, $24 trillion. And I sometimes, though I have put those figures in some of those reports myself, but sometimes I feel, this is like a kid talking about something very complex. Yes. We are still not there for having a reasonable assessment of what the ocean means to us. Yeah, for example, one of the presentation is about, for example, the accounting. Now, how do we account something which we don't even understand? Yes. And that is what the ocean is all about. We are given the advantages of technology, given the advantages of mega data analysis and artificial intelligence. When it comes to the ocean, we are still the beginners, in fact. We're just at the initial stage. When it comes to, somebody mentioned about traditional knowledge. I recall again, I have probably done it in the past. I happened to be in Peru, and these Incas and Mayans, thousands of years ago, they could predict when the El Nino or La Nina was coming. Yes, they didn't have technology. They had no satellites. They had no chemical analysis. They had no physical things. But sheer, because their experience of living with the ocean. Yes. So they would see the behavior of fish. They will see the behavior of birds. They will see the behavior of clouds and all that stuff, and could very accurately predict that this year El Nino is coming, right? And then, because they could predict it several months in advance, they were able to take measures for mitigation of consequences. Yes. Now, today we have tremendous amount of technological support, which they didn't have. Yes. And as a result, our prediction of our partner, whether the partner is happy or unhappy with us, I think we have the tremendous asset in our hand, and we can predict that state of mind of a partner called ocean. And then can plan both ways, either to enhance the outcome that we have with the partner or minimize the impact of its consequences if it is angry with us. Right? So that is what MSP is all about. What are we trying to do in MSP? We are trying to understand the causes of things, because things do not happen in isolation. It takes time for various factors to work together and then come to a combination which results in something adverse or a disruption. Now, do we understand those pathways? Yes. What are those pathways which result in ocean acidification, ocean warming, loss of biodiversity, all those things, or the migration of species, all that stuff? So if you're able to understand those pathways, which are heavily data-driven and in real time, you can't say, okay, yesterday I have measured it, so today I can forecast or extend or extrapolate that measurement. No, that is where, in fact, the digital twinning, I know we can never, in my lifetime, we won't have a digital twin of the entire ocean. Yes, it's impossible. But I know that because whatever we may say, we are the superpower in terms of creature or in terms of evolution. But we play in a very small area of ocean. Yes. How much of an ocean we cover through human activities is negligible. And that negligible space, our activity is so intense that it hurts the entire ocean. Can we understand that space? Yes. A factory which may be polluting maybe in 5,000 square meters, but it will impact entire village or entire city or entire nation. So we have to concentrate on those areas where we are active and then understand how far we are damaging our partner. And this is where I think whole MSP on which you are working, Arnab, so closely, becomes very relevant. We should think of 100% ocean because it will take care of itself. Because we are not there, right? So, but where we are, ports, the fishing areas, the naval operations, this cable laying, energy extraction. Now, if those areas we understand and we are able to create what is called models and simulation route for that, which means the same go back to the Incas and Mayans. They were seeing something happening. And based on that, they were predicting what will be the consequences now. Yes, so El Nino is a very complex phenomenon. They had no science, but they were measuring. They were seeing, oh, this is happening. That means something is happening. And when they analyze those 3, 4, 5 parameters, they could come to the conclusion, yes, this year is an El Nino year. And they were most of the time very accurate, which means developing those markers. Arnab, I have mentioned that earlier also, right? The whole idea of simulation and modeling is to develop those markers. When you see those markers, you should be able to see what's going to be the consequences. I always say I'm taking the human equivalence. There are blood markers. With one marker, they will tell you whether your kidney is working well or not, or your heart is working well or not. So this is what data is here for. Data can help us develop those models, which then by looking at certain symptoms, we'll say, oh, here is the disease, है. Bimari ka more or less 90% we can get to the bimari or sickness or the illness based on a particular marker. Now, if you're able to do that in respect of oceans, I think we'll do a great service to the oceans. We'll do a great service to humanity as a whole. So I think, Vadhvan, you know my views on these matters, and I'm very happy that because most of the time we talked, I used to say, can we take UDA framework for finding real life solutions? Because pure technical and scientific understanding of this will not carry us that far. Can we solve the day-to-day problems of people? If we are able to do it, believe me, people will be with us. But if you are not able to solve it, they will say, okay, go to your lab, do your work, feel happy about it. I have nothing to do with it. Yes. So I'm very happy that you brought in the non-technical team, because I was always worried that we run the risk of defining UDA mainly in techno-security framework. And that would not be right. Because the mandate of what you do will come from people, in fact. It is the economics of what you do. It's the sociology of what you do. It's the history of what you do. It's the international relations of what you do. Unless we combine all that together, people will not stand behind us. Right? They will see us, we live in our own, kind of a niche, and we are trying to impose our niche on them. Let's find their solutions. Let's solve their problems. And then they will be with us. And this step which we have taken now, this will help us do that. When the economic students go back to their colleges and start talking about UDA and the oceans, when the sociology students do it, when the English honors does it, I think a lot of a job will be done by this. Yes, carrying the message to the people. Because they sometimes don't understand these complex technical terms. They feel very tired of this. Can we convert that language into the language of ordinary people and explaining to them that there are solutions for their problems? Then only the job will be done. Yes. So with these words, Arnab, I once again congratulate you. I congratulate all presenters. And if they wish to talk to me anytime, I'll be very happy to talk to them. Since it's all our own in-house, something stuck my mind. So I was kind of reading a little, a report on, because I read a lot of history and all those. So this was like Ramayana, for example. You see, when Ram gets stuck at the ocean and he has to cross it, yes, doesn't know how to cross it, yes. And then one of the options was use the Agni Shastra and dry the ocean, burn it down, yes. Ram said, we are terrestrial people, we are land-based people. Who was the coastal man there? Vishen was the coastal man. He goes to him, he says, do you have a solution? He says, ask the ocean. It will give you a solution. Yes. Don't burn it down. Talk to it. Yes. And finally, he talks to the ocean and ocean gives a solution. Yes. Rather than burning it down, it provides a solution. He says, here is the solution. Why do you want to burn me down? UDA will provide us that dialogue tool of talking to the ocean rather than burning it down. Yes. So I think with these words, I'll stop. But as I say, any participant, if you want to talk to me on any of the issues, I'll be very happy to do it. Thank you.
Thank you so much, sir. Sir, Calistine has started this work on how UDA can impact global order. And today, with so much less time, we have to discuss with you on this in a very detailed way. He has started on the very fundamental theoretical concepts of how politics impacts global order and economics, environment, demography. Starting from the very fundamental, basic theoretical frameworks that have evolved and how various commentators have done a very thorough literature survey and then situate UDA on this and how it will impact. So that is something fundamentally work that we have started, and there is a lot to discuss with you on that. And as we had discussed, if you remember, on the climate change, so we have, multiple people working on climate change, and you just saw one presentation here, but we are taking that very seriously and kind of building the entire thing. And what you saw, Anvi's project is to kind of connect at a little more micro level to the larger, modeling and simulation driven MSP, and how MSP will then add up to the economic model. So we are trying to build that up. So, it's still work in progress. Some of these interns who have presented today, they have not even been with us more than 15 days. But these students come from a good institute, so they are able to pick it up well. But there is a lot more work to be done, sir. And even the writing will require a lot more work. And today is, I would say, more of a preliminary presentation in terms of kind of defining what their work is. And this will require a lot more polishing and a lot more work. And we will definitely keep you informed on the final outcome of their work. They still have, this batch of students have at least 6 more weeks with us to kind of bring this to a little more matured level. So,
2 minutes or less than that. You took me, in fact, you kind of reminded my mind. Somebody talked about decolonization of UDA. Yes. Under the BBNJ, I hope, this biodiversity beyond national jurisdiction. Under this Oceans Treaty, you want to do anything in the oceans, the complex requirement of environment impact assessment is hugely complicated. And unless we understand UDA well, we run the risk of being colonized. We'll have to utilize not only the foreign technology, but also standards in terms of doing environment impact assessment of any project that we do on the high seas. Now, if without UDA, can we imagine doing environment impact assessment in the oceans? No, because the impact is underwater. So unless you understand underwater, how do you do the assessment? Yes. So therefore, I think people must start thinking in those terms. That modeling and simulation. Can we create some modeling simulation for environment impact assessment under controlled conditions? So that tomorrow when somebody says, we need environment impact assessment on the high seas, India should raise its hand and say, yes, we can do it. Yes? And not simply stay quiet and say, all right, aap karke bata dijiye. Yes? So, these are real life problems which we are going to face in the future. And I have said that so many times in the past that without UDA, you do not understand these things. Yes. Thanks.
thank you so much, sir. Catherine, back to you.
Thank you so much, sir. It was a really nice experience to actually understand and get your feedback, Rear Admiral Sanjay Dutt, and as usual, Anup Mutkal, sir. Because I think now the interns will use all of those feedback to help address the issues and the shortcomings that they had till this point. So, and it also gives us mentors a lot to think about. And moving on, we have Nishtha. We have come to the end of the session today. So Nishtha will give the concluding remarks. Thank you so much. Thank you, everyone.
Thank you. Thanks so much, Catherine. And thank you so much for allowing me this opportunity to do the closing remarks. But before I do the closing remarks, I do have, something to share, which was encouraged to me by Arnab sir, that I talk about how communications has become a strategic pillar for the growth of Maritime Research Center. And, my experience of handling the communications and outreach at MRC. So I'd like to share my screen to speak a little bit about the same. So my name is Nishtha, as Catherine introduced, and I handle the communications and outreach at Maritime Research Center. I'm also involved in promoting an e-magazine that we run, which is called the UDA Digest. And, a platform has over 140 articles and, on across the topics that are associated with underwater domain awareness, including blue economy, marine spatial planning, biofouling management, etc. So in my presentation today, I want to talk about, how communications has acted as a strategic pillar for the growth of Maritime Research Center. I think one of the major things that we look forward to and we do as part of the comms and outreach is that we want to make sure that we have a global presence and the credibility across the world, and for which we want to enhance MRC's national and international visibility through strategic digital engagement. We also want to strengthen the institutional credibility by consistently showcasing the research output of the work that, which is being spearheaded by the engineers at MRC, by the researchers at MRC, and the fellows and interns that we have. We also focus on the strategic network and partnerships. I think this forms a very core pillar of the reason why, us as an organization has been growing, is because we like to facilitate collaborations, and we have collaborations with the top level academic institutions of the country. At present, we have collaborations with industry partners and government agencies. And as part of the comms, we try to promote the webinars and arrange for these webinars and workshops so that we have more participation and support the capacity building by highlighting the internships and knowledge sharing opportunities that are there at MRC. Apart from that, we want to establish ourselves, and we've been able to establish ourselves as a thought leader amongst the community. And the community includes all kinds of stakeholders, including the coastal community as well. We promote interdisciplinary dialogue on emerging underwater domain challenges. I think this workshop, this webinar is a proof to that in itself, because in the previous two workshops that we did with our interns, we had students from technical institutions such as IIT and BITS Pilani. But this particular one is dedicated for the students who come from the liberal arts background. This in itself speaks about how UDA framework is an all-inclusive framework instead of just being very highly technical in nature. So that's something that helps in the the strategic communication aspect as well. The other thing is we want to strengthen the research work that our team does on various topics, including blue economy, which is driven by Catherine herself, or geopolitics and IR is also one domain under which we have a lot of work, which is there on our website, which is there on our social media platforms as well. And as part of the communications, we try to broaden the digital engagement as much as possible. And the activities include that we have a lot of research articles and policy related articles on our UDA Digest platforms. We keep arranging a lot of webinars and expert lectures, and we do newsletters. We come out with different forms of multimedia activities, including the videos, the explanatory videos that we do, or the expert lectures that we have. Also, one thing that stands out for us in terms of the digital engagement is our social media presence at the moment. So we have a very strong digital presence at the moment, be it through the website that we have, or the social media platforms that we have, or the magazines that we have, or the various web pages that we have, which are dedicated to the repository of the research work that we do, the videos that we come out with. So all of this encompasses the outreach and the communication aspect, and acts as a strong pillar for the growth of Maritime Research Center. Besides, I have also worked on a project called the 100 Warriors Initiative, and I was encouraged by Dr. Commander Arnab Das to talk on the same and to speak about it. So 100 Warriors Initiative is part of, our community engagement and heritage driven aspect of UDA framework. And this has been crafted and developed by the Maritime Research Center. This is primarily designed to raise awareness about the sustainable ocean practices amongst the coastal communities and the water dependent communities. It covers three different stakeholders: the people who are from the coastal communities, people who come from the riverine communities, and the others who are whom we call as the water warriors. They're the ones who are water dependent communities. So these are the major focus of the 100 Warriors Initiative has always been to empower the youth of these particular communities, and it intends to introduce new employment avenues and achieve economic generation for the community, the coastal community and the riverine community, etc. So this in itself speaks for how UDA framework is not just just technical or scientific in nature. It is also very community friendly, wherein it wants to promote ways through which even people from these communities can come up, and they can also become part of the mainstream of the society, and they have the avenues of employment generation as well. So it benefits the fisherfolk communities in socio-economic, socio-political, and socio-cultural areas, this 100 Warriors Initiative, and it supports biodiversity by ensuring sustainable use of ocean resources. So this is brief about the 100 Warriors Initiative. There are a lot of material on the 100 Warriors Initiative that you can find on our platforms, on the digital platforms as well. So in this slide, I want to show you about the growing prominence and relevance of the work that we do. We have been, rising, we have risen in various sectors. So there's influence, we are trying to influence not just the local community, but the national and international community as well. And it is done through like these kind of platforms, these kind of dialogues that we arrange, wherein we have international organizations also who partner with us to become, a part of the research work that we do. And we do publication related collaborations as well. We've recently partnered with Springer Nature to come out with a research publication. In the past, we've done a special publication with ICWA, which is Indian Council for World Affairs. So this cross-sectoral influence is also something that has led to the growth of Maritime Research Center. Other than that, MRC is a very collaborative ecosystem. It promotes a very collaborative ecosystem because we have experts, we have fellows, we have students, interns, so many organizations, government agencies, and think tanks, international think tanks based in Japan, based in US, based in UK, who have partnered with us in the past, and they continue to partner with us to expand the knowledge partnership networks across the globe and talk about this concept of underwater domain awareness. Apart from that, the other reason is the digital footprint expansion. I think we're trying our best to, project our work in the best way possible across our social media platforms. And we've seen a tremendous growth in terms of the number of people who've been following us on our social media platforms, especially LinkedIn. I think LinkedIn has really stood out for us, and it has allowed us for a platform wherein we are reaching out to a lot of people, showcasing the work that we do, showcasing the partnerships that we have, and how we want to influence at the level of decision making, at the level of policy making. And this is done by strategic outreach and communication through regular content posting, through targeting the right kind of audience and engaging with the right kind of stakeholders. It involves a clear messaging that reaches the decision makers and influencer, and that is, has always been our driver of communicating to the world what we do, what is the research work that MRC does, etc. So with this, I would like to end my presentation. This is mostly what I wanted to speak about. For the closing remark, I think I would like to start with thanking Dr. Commander Arnab Das and Catherine for arranging this this webinar and coming together, and for all of you for coming together, and to all the interns who made the presentation today, because it is as is always said that UDA framework is inclusive. That means that students from the liberal arts background are and their research work is as important as somebody who's coming from a science and tech background. That's the beauty of UDA framework, I feel. And I would like to thank our experts, Rear Admiral Sanjay Dutt and Ambassador Anup Kumar Mudgal sir, for their kind remarks. I think I'm going to take back all of what was shared by everyone, especially the experts. So yeah, with this, I would like to close today's session. Thank you so much for joining. Have a nice day. Thank you so much.
Thank you, Nishta. Sir, a quick word, if at all, Mudgal sir and Sanjay sir. Mudgal sir, maybe.
No, I think this has been a very, very, exciting experience today. Because most of the time we have been talking about the tech aspect of UDA. Today we are going to the people, and linking what we do to the ordinary language was important. And I'm sure today's exercise will achieve it. As I say, I would just want to repeat, in any of the present presenters or interns, if they want to talk to me on anything, I'd be very happy to do it. Arnab, you can share my number with them. Just send me WhatsApp, tell me what time, I will be happy to talk to them.
Sir, Catherine will do that part, sir. I mean, in smaller groups where we are not worried about time, we will sit and discuss with you on each of those aspects. And I mean, I know these are all, I've been telling Catherine about this, that these are very close to sir's heart. And I mean, I would be trying to also be part of it, but at least Catherine will anyway engage with you to make sure that we get more time with you, sir.
Thank you.
Thank you, sir. Thank you. Sanjay sir, please.
Sir, Ambassador, sir, Dr. Arnab Das, like I've always seen him in the IIT itself when I was there, and of course all the presenters. Sorry, I'm not familiar with so many names at this moment, but thank you so much, because I think it's important that this is a convergence of tech with arts, and it brings out a lot more from the actual real. And as the ambassador said rightfully, that we tend to think more of the technology, but we don't think about the other aspects of it, and perhaps that's the reason why we have not progressed in that manner. So I think this is a very right forum. More interestingly, it is touching a topic, as he rightly said, that the ocean is our mother of life, and it is taking us back. So we have to go back to the ocean to learn much more than what we know. The only thing where I'll probably, on an optimistic note, I'll say that perhaps if we put in an effort, we may be able to make the digital twin. But yes, sir. Thank you so much once again, all of you, and to all the brilliant presentations and a brilliant interaction. Thank you so much. And I'm also available in case anybody wants.
Yes, sir. Yes, sir. We'll do that.
I have all the time in the world.
No, sir. I want to do that. I mean, that's the reason I invited you here. But I mean, with the tech team, I would like to have, a little open-ended, so that we are not rushing with time, and we'll discuss in more details and seek your inputs from there. Thank you so much, sir. Anup, sir, thank you so much, sir.
Thanks a lot.
Catherine, Calistine, everybody. Thank you so much.
Have
good
a good
presentation.
Day.
Thank
right.
you.
Thank you. Thank you, sir. Thank you.
Shreya, thank you very much for the back-end support. Good job. Thank you,
sir.